Welcome all of you. Today in this lecture we are going to study preparation of carbolic acids. In previous lecture we studied what are carbolic acids, classification of carbolic acid into aliphatic carbolic acids and aromatic carbolic acid depending on whether the carboxyl group is attached to alkyl group or aromatic ring, and then nomenclature of carbolic acids according to common system and IP system. In common system, the names of carbolic acids are derived from the name of the source of substance from which they are derived, and in IP system they are named by changing ending E in the name of parent alkane by OIC acid. Now see preparation of carbolic acids. There are 6 methods of preparation of carbolic acids. First, from alkyl nitrites and amides. Second, from acyl chlorides and acid anhydrides. Third method is from esters. Fourth method from alkyl benzene. Fifth method from alkenes. And sixth method from Grignard reagent. Now see first method from alkyl nitrites and amides. Alkyl nitrites and amides on hydrolysis gives corresponding carbolic acids. So alkyl cyanides on hydrolysis first gives amides, and which on further hydrolysis gives corresponding carboxylic acids. Now see here, first general reaction is given here. This is the representation of alkyl cyanide or nitrile. That is functional group is C triple bond N. Now hydrolysis means addition of water. Now here one bond breaks here, and here OH get added on this carbon and H get added on this carbon. So it is what is here RCOH. Now there is a double bond NH. Now see here there is a internal rearrangement of atoms takes place, and that is known as tautomerism. So this one bond breaks here, and bond between O and H breaks, and new bond between C and O is formed. So see here, and this H get added here. Means what? N forms bond with this H, and carbon form bond with this O. Okay, so there is double bond between carbon and oxygen, and this is known as tautomerism. Now H get added here, and this double bond get added here. So what is here? RCONH2. So this group is known as a amide group, and one more molecule of H2 get added here. Now here bond breaks, and OH added here and H added here. So what is the product? RCOOH plus NH3. Means what? One molecule of nitrile or alkyl cyanide requires 2 molecules of water to form corresponding carbolic acid. So in one step you can write like this. Now see here, this is the example. This is a methyl cyanide, or it is also known as a ethane nitrile. Now one H2 here and one H2 here. Total 2 molecules of H2 are required. So plus H2O, and hydrolysis reaction takes place in presence of acid. So it may be HCl or H2SO4. So product is CH, this COH and NH3, and this NH3 and HCl forms NH4Cl. So H3 NH3 or NH3 and this HCl forms NH4Cl. This is the preparation of carbolic acid from alkyl cyanide or nitrile, and from amide, because in this reaction the intermediate product is amide. So you can take amide as a reactant. So this here RCONH2. Its name is acetamide. You remember this name. I have not given in the notes, as well as there are no names in the textbook. So you, while reading the notes, you write the names of these reactants as well as the products. Here methyl cyanide or ethane nitrile. This is acetic acid. This is known as a acetamide, and again this is acetic acid. So this is first method of preparation of carbolic acid. Now second method is from acyl chlorides and acid anhydrides. Now acid chlorides and acid anhydrides on hydrolysis water gives corresponding carbolic acids. So direct addition of water takes place here. Now RCOCl compounds are known as acid chlorides. RCOCl. These compounds are known as acyl chlorides. Now example is CH3COCl. Here alkyl group is CH3. Its name is acetyl chloride, and plus H2 here bond breaks here. Okay, and now C forms new bond with OH in water. So CH3COCl becomes what here? CH3COH, and this replaces H and H, remaining H from water, forms byproduct HCl. So this is simple reaction. HO2 get added here. And from acetic anhydride, so reactant here is in place of acetyl chloride, acetic anhydride. Now this is example of acetic anhydride. How this compound is formed? This compound is formed by removal of water molecule from 2 molecules of acid, and the water molecule is removed by using dehydrating agent like phosphorus pentoxide. So here CH3COH, CH3COH, 2 molecules of acetic acid. Now 2 hydrogen atoms from 2 molecules and 1 oxygen atom from any one molecule forms H2O, and remaining part is CH3CO2 and 1O. This is known as acetic anhydride. Now here same reaction is there. Here CH3COOH, and second one CH3CO, this O and remaining H. So 2 molecules of acetic acid are formed if the reactant is what is here? Acetic anhydride. This is second method of preparation of what is here? Carboxylic acids. Now third method is from esters. Now esters on hydrolysis gives corresponding carboxylic acids and alcohols. It is esters when boiled with dilute sulfuric acid or dilute hydrochloric acid gives corresponding acid and alcohol. Now here example given is CH3COCH5. So name of this compound is ethyl acetate. This is the common name, and ethyl ethanoate is IUPAC name of this compound. This is R. This is another R, and this is function of COO. So RCOO R dash means what? It is the representation of ester. So here one alkyl group is methyl, another is ethyl. So this is an example of ester, and name is common name is ethyl acetate. Now plus H2 gives 1 molecule of acetic acid and 1 molecule of ethyl alcohol. Now see, we studied this reaction in the topic alcohols, chemical properties of alcohols, esterification. Alcohol and acid, when heated with concentrated sulfuric acid, water molecule is removed from these 2 molecules to form corresponding ester. This here OH from acid and H from alcohol forms H2, and remaining what is here? CH3CO, this O, H2H5. And here the reaction is reversible. So this reaction is a formation of ester. It is known as esterification. And reverse reaction is a dissociation of ester into acid and alcohol. Means what? When water molecule is removed from acid and alcohol, ester is formed. So if water is added in ester, then definitely alcohol and acid will be formed. So bond will break here, and OH get added here and H get added here, and 1 molecule of acetic acid and 1 molecule of alcohol is formed. So in short, forward reaction is hydrolysis, that is conversion of ester into acid and alcohol, and this backward reaction is a formation of ester from acid and alcohol. It is known as esterification. Now you know hydrolysis can be carried out by using mineral acid or alkali. If alkali is used for hydrolysis, then product is sodium salt of acid, not acid. And as sodium or potassium, salts of higher fatty acids. Higher fatty acids means acids containing higher alkyl groups, C16, C17, etc. They are known as higher fatty acids. And sodium or potassium salts of these higher fatty acids are soaps, and therefore the alkaline hydrolysis of esters is known as saponification. Now here see example again. This is a same CH3. This is methyl ethyl acetate. Now here 2 and 3 carbon atoms are there. Means what? This ester is formed from methyl alcohol and propionic acid, and therefore its IUPAC name is methyl propianoate. and common name will be methyl propionate. That is rule is same. In ending ice acid in the name of corresponding acid is replaced by AT, and prefix is alkyl group from alcohol. If we want common name of ester, then we have to take the common name of acid. And if we want IUPAC name of ester, then we have to take here the IUPAC name of corresponding acid in that ester. So this is the IUPAC name of this ester, methyl propanoate plus dilute NaOH. Now here this is from acid part and this is from alcohol part. So corresponding salt will be formed. So C2H5 COO and this Na. So this is the sodium propanoate. This is sodium salt of propanic acid. Its name is sodium propanoate. And here this CH3 and remaining OH. This is by another reactor product is methyl alcohol or methanol. Now this is a sodium propanoate, and when this is acidified, then again what happens here? Again this salt is converted into acid. So here this Na and this OH form again byproduct NaOH, and remaining H get added here. So C2H5COOH. So it is what here? Propionic acid is a IUPAC name, and propionic acid is a common name of this acid. This is the third method of preparation of carbonic acids. Now fourth method is from alkyl benzene. Now alkyl benzene, when treated with oxidizing agent, acidic or alkaline KMnO4, dilute nitric acid or chromium trioxide, then gives corresponding aromatic carbonic acids. Alkyl benzene means hydrogen atom in benzene is replaced by alkyl group CH3, CH5, etc. Now one more thing in this reaction is irrespective or regardless of length of carbon chain in alkyl group, whole alkyl group get oxidized to corresponding carboxyl group. Only limitation is if the tertiary alkyl substituted on benzene is not oxidized. Now see here the example. This is the benzene ring, and carbon atom, one of the 6 carbon atoms is replaced by this CH3. So this is methyl group, this is benzene, and therefore it is known as a methyl benzene. This is example of alkyl benzene, and the another name for methyl benzene is toluene. Now this is oxidizing agent. Acidic or alkaline, here it is a KOH means it is a alkaline KMnO4. Now directly this group get converted into corresponding salt, and it is when hydrolyzed, means what again heated with that acid, mineral acid, then what is here? This is a COOH, means what? Similar to previous reaction, the salt again get converted into acid when it is acidified. So what is the name of this compound? This is aromatic acid. COH group means what? Carboxyl group is directly attached to aromatic ring or benzene ring, and its name is what here? Benzoic acid. It is used both in common system as well as IUPAC system. Now here another example. This is a cumene. Means what? Here alkyl group is isopropyl benzene. Here the isopropyl group 1, 2, 3. C3 H3 3 and 1 7. C3H7 means it is a propyl group, third alkyl group. Then this carbon to which benzene ring is attached is a secondary, and therefore this alkyl group is known as a isopropyl group. And you know this compound, okay? This is known as a isopropyl benzene or cumene. This is used in the preparation of phenol. Okay, in the preparation of phenol, we studied this method. Second method or preparation of phenols is from cumene. Then now see here cumene or isopropyl benzene. Here actually there is a chain of 3 carbon atoms, but here this whole alkyl group, there may be 1 carbon, 2 carbon, 3 carbon, 4, whatever number of carbon atoms in that chain. That group is directly get converted into this first salt and then direct COH group. So again here what is here? Here there is 1 carbon, final product is benzoic acid. Here there are 3 carbon atoms, then also the final product is same benzoic acid, means what? Irrespective or regardless of length of alkyl group which is attached to benzene ring, whole alkyl group is oxidized to carboxyl group. Now here generally here reactions are balanced reactions not given, but you remember one thing: if carbon and hydrogen is there and if oxidation is reaction there, then carbon get oxidized to carbon dioxide and hydrogen get oxidized to H2, C plus O to CO2, H2O plus O, H2O. Means what here? The byproducts are definitely carbon dioxide and water. So this is the fourth method of preparation of carbolic acid. Now fifth method is from alkenes. Now you know what are alkenes? Alkenes are unsaturated hydrocarbons containing at least one carbon-carbon double bond and having general formula CnH2n. They have two hydrogen atoms less than corresponding alkenes. Now when this is also again oxidation method, alkenes are treated with oxidizing agent acidic potassium permanganate, then get oxidized to corresponding carbolic acid. Now here example: C6H5CH double bond CH2. Now CH2 double bond CH2 means it is a C2H4. It is a first member of alkene series. Its common name is ethylene and IUPAC name is ethene. C2H4, and what is the structural formula? CH2 double bond CH2. Now this compound is a derivative of ethene. Means what? Here one hydrogen atom in ethene is replaced by C6H5, which is a phenyl group, and therefore the name of this compound is a phenylethene. Now this is again oxidizing agent acidic potassium permanganate. Now product is C6H5 and COH. This is benzene rings here, and this name of this compound is a benzoic acid. Now here C6H5 COOH. So in place of this double bond breaks, and in place of this double bond, that is CH2, there is what is here? 2O. One O is added to H and one O double bond with one O. So C double bond O single bond OH, and this C will form CO2, H2 will form H2O. So here one O, here 2O, and here 2O. In all, 5 oxygen atoms will be required here, and these oxygen atoms are supplied by this mixture, and therefore it is known as a oxidizing agent. The substance or mixture which is responsible for oxidation of this reactant is known as a oxidizing agent. Now one more example is given here, that is cyclohexene. Now if there is no double bond, then it is a cyclohexane. Okay, if there is a alternate single and three double bonds alternate, then it is a C6H6. If there are no double bonds, then it is a cyclohexane. Its molecular formula is a C6H12. Now here there is one double bond. Means what? Here out of the 6, this carbon, this carbon, this carbon, and this carbon carries 2 hydrogen atoms. Okay, but here this carbon carries 1 hydrogen and this carbon carries 1 hydrogen. Means what? As there is one double bond, there are 2 hydrogen atoms less than corresponding cycloalkanes, and therefore the molecular formula of this is what is here? C6H10. C6H14 means aliphatic. C6H12 means it is cycloalkane, and cycloalkanes means again 200 atoms less. So it is C6H10. So here this bond breaks. Here C and H, here C and H. So here 2 O atoms get added, and here 2 O atoms get added. So COH and COH. So this is known as adipic acid. Here COH, CH2, 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 and COH. This is open chain compound. It not change closed here. So this is used in the preparation of nylon fibers. And now the last method is from Grignard reagent. Now you know how the reactions of Grignard reagent takes place. Grignard reagent always gives additional reaction with unsaturated compounds. Means what? There must be either double or triple bond, and these are addition reactions. So when a Grignard reagent is treated with solid carbon dioxide, which is known as dry ice, gives a complex or addition product in presence of dry ether, which on acid hydrolysis gives corresponding carbolic acid. Now here example. This is an example of Grignard reagent CH3MgBr RMgX alkyl magnesium halide is known as a Grignard reagent. Here alkyl group is methyl, halide is Br, and this is the symbol of magnesium. And name of this compound is methyl magnesium bromide. And this is the formula of CO2. Carbon atom is bonded to two oxygen atoms by double bond, and here double bond. So there are 4 bonds of carbon and 2 bonds of each oxygen atom. So this is known as a dry ice solid carbon dioxide. Now see how reaction takes place. As usual, this methyl group get added here on C, and Mg get added on oxygen. Now this bond breaks and bond remains as it is. So this remains as it is. So what is the product here? CH3CO as it is. Here CH3, CO, and this O, and this MgBr. So CH3COO MgBr. This is addition product or addict, which is intermediate product in this reaction. And this is followed by hydrolysis. Means what? In the second step, this product is a reactant. Now here this bond breaks here between C and Mg, and H from water added here. So CH3 COOH, and remaining MgBr, and this OH forms byproduct. So this is what here acetic acid or ethanoic acid is the IUPAC name. So these are the 6 methods of preparation of carbonic acid. You first try to remember the names of methods, and then if you remember names, then in the names there is a name of a main reactant, at least one reactant. Then it will be easy to remember the reactions. So we'll conclude here. Thank you.